Okay, so next up we're going to see the division property with exponents. Basically, if you think about yesterday, when you were multiplying things, you ended up adding the exponents. So today you can kind of assume if we're dividing, we will subtract. But let's see how it actually works mathematically. If you had, let's say, just an x and it was being divided by x cubed, well, that's just one x on the top, right? But that's 3 of the x's on the bottom. And so then, if you can cancel out pairs like that, and so what's left on top, if everything cancels, it would just be 1, and on the bottom, it would be x squared. But again, I could have just subtracted those exponents to kind of get there. We're going to see what it actually looks like here. A cubed, I like to circle the things that are the same. So 3 minus 2 is just a regular old x. And 4 minus 1 is just a regular y cubed. Okay? So here's the next thing I need you to know. If you have an exponent of 0, that cancels. So think about for a minute how that works. If I have, well, let's see, I'll do my x squared y over x squared z, let's say. So what you really have is 2 x's on both the top and the bottom. If you're showing your work and really writing it out, those just cancel, right? Okay, and your answer is just yz, or y over z. But over here, if you had done 2 minus 2, you would have ended up with x to the 0, y over z. Well, again, x to the 0 is just 1. So this really cool thing happens on 3b. I have all sorts of fancy schmancy stuff going on in here, but I have an exponent of 0, so the whole thing just becomes 1. All right, so when you do that subtraction, it actually always ends up on top. So my very first example is kind of confusing when I started pulling it to the subtraction. But let's try like 4a. What happens here, the first thing I would do is pair things up and do your subtraction with the exponents, and everything is going to end up on top. When you subtract the top or the bottom from the top, meaning the top number minus the bottom, it's going to end up on the top. So v to the negative third, there's nothing to combine with it. W's, 1 minus 1 is 0, that cancels. There's nothing to combine with the x. If there's nothing to combine with the y, since it's already on bottom, I'm going to leave it there. But now here's the thing with negative exponents. It turns out negative exponents are the same thing as having a positive exponent if it's on the other side of the fraction. So do you see how this v to the negative third is on top? If you just move it to the bottom and make it positive, that's actually the exact same thing. Pretty cool fact there. Since x squared is already positive, I'm going to leave it on top. Now I'm noticing y is negative, so I'm going to move it to the top since it's already on the bottom. Let's try 4b. The first thing I need you to remember is normal numbers do normal number things. Don't subtract these. Either simplify the fraction or do division. 32 over 4 simplifies to be 8 over 1. Now let's do our a's, and again, those are going to end up on top. So negative 8 minus 3 is negative 11. And then we have 3 minus 5, which is negative 2. And then we have negative 4 minus a negative 2 is a double negative to give me negative 2 again. And then because all of these are negative, they need to get moved to the bottom. I notice that I don't actually really have to write the 1, right? We never have to write a multiplier of 1. The 8 stays on top. And then it's just a to the 11th, b squared, c squared. That's my answer. Okay, I want to do another example. Will one of these work? Yes. Let's do number 16. Actually, we're going to do 16 in class tomorrow. That's what we're going to do. Be prepared.